Okay. Can we start? I think only 38 members are there. So almost 5 minutes I waited. So this is not the good sign again. Okay, let it be, no problem. We have discussed in the last class. Can anyone summarize? I think we are meeting after long gap again, almost maybe 10 days. Hmm? Can anyone summarize what we have discussed in the last lecture? Quickly, so that we'll just move ahead. Anybody? Supriya Pawar is there? Supriya Pawar. Can you summarize, madam, what we have discussed? Yes?
Process. Design and idea pass filter.
Design? Hello? Yes, madam, please speak up.
Hello. Assignment question चालू होते सर.
Assignment question solve केला होता. So you just summarize what we have discussed in the 5th chapter so that I can move ahead with the next topic. Can you summarize? So what are all the things we have discussed in the 5th chapter? Okay. Uh, Pallavi is there? Pallavi? Pallavi?
Yes, sir.
Can you summarize what we have discussed in the 5th unit?
Yes, sir.
Yes, madam, please.
Introduction to FIR filter.
Okay.
Design of FIR filter using rectangular Hamming windows. FIR filter design using frequency sampling technique. FIR implementation techniques.
Whether we have covered all these topics? I think you are reading the syllabus. Pallavi.
Yes, sir.
I not asked you to read the
नंतर
syllabus.
त्याच्यावरचे एक्झाम्पल सर आपण घेतले होते.
Oh, madam, syllabus संपला मग syllabus सगळं? According to you, then the syllabus is over. पहिला लेक्चर मध्ये जोक करायला लागला का मॅडम? Yes. Who will tell me proper summary? Prajakta is there? Prajakta Avtade.
Yes, sir.
हाँ मैडम, आप बताएंगे?
Yes, sir. In this chapter, we have seen FIR filters introduction.
Okay.
Then comparison of FIR and IIR.
Okay.
Finite impulse response and infinite impulse response.
Okay.
Then we have seen Gibbs phenomenon.
Okay.
Then we have seen design problems.
Okay. Design problem related to what?
Hamming windows.
Direct Hamming window.
No.
त्याच्या आधी तुम्ही
Ideal low pass filter, ideal high pass filter,
Using which method?
frequency response.
ठीक है, आधा पार्ट बराबर है आपका. Okay. Next. Other person. So who will tell me the correct summary, what all we have discussed. Gayatri is there. Gayatri Bhandare, roll number 7.
Yes, sir.
हाँ मैडम, आप बताएंगे मुझे.
Sir, same project, sir.
You tell
वैसे
it. What like same cut paste मत करो. आप अपने हिसाब से बताओ.
वही मैंने भी लिखा है सर, उसने वो बताया वो।
इसके अलावा दूसरा कुछ नहीं लिखा है आपके पास.
नहीं सर।
ओके. तो मतलब आप लोग प्रॉपरली नहीं लिख रहे, इसका इंटेंशन होता है. So people are not at all noting the things properly. Let me say somebody else. Otherwise, I will tell you like what we have discussed. 19 is there. Vaishnavi Surva se. Roll number 19. Roll number 19. Okay. Roll number 21.
Yes, sir.
Can you summarize, madam?
Yes, sir.
Hmm.
In fire filter design chapter, we first seen the types of digital filters. That is a fire filter and IR filter. After that, comparison of FIR and IR filter.
Hmm.
Next gives phenomenon.
Hmm.
After that, design of FIR filter using Fourier series method. In this, we just seen the steps for solving the uh, designing of FIR filter.
Hmm.
Designing of ideal high pass filter and low pass filter using Fourier series method.
Okay.
After that, types of window. In types of window, in syllabus they are given Hamming window, Hanning window. We see all the types of window, and after that, at the last, we take the problem on Hamming window.
Okay. So hope everyone has understood this. Gayatri, Prajakta, Supriya, who else I have asked. So please correct yourself wherever you are having a shortcomings. So in the first, like in the unit 5, we have discussed about introduction to FIR filter. After that, the types of FIR filter, like FIR, so types of digital filter. In that digital filter, we have discussed like two types. One is FIR filter and other one is IR filter. Then we have seen the comparison of FIR and IR filter. Then we have started with designing of FIR filter using Fourier series method. Then we understood the step by step how the designing of the Fourier FIR filter can be done using a Fourier series method. I think around 9 steps I have given you, like step by step for solving these examples of related to FIR filter design. Then we have solved the examples on FIR filter design for low pass filter as well as high pass filter based on this Fourier series method. After that, we have discussed the windowing technique method, the different types of windowing technique methods we have discussed. In that, I think we have started with rectangular, then triangular, then Hanning, Hamming, Bartlett, and Kaiser. And at the end, a summary of all these types of windows we have discussed. And then we have looked at the example of Hamming window as well as the rectangular window, like low pass, high pass, and the band pass filter. Now, today's topic you just write down, please. So we are going to discuss today. The title is a frequency sampling method of Just write the title. Frequency sampling method of designing FIR filter. Frequency sampling method of designing FIR filter. Frequency sampling method of designing FIR filter. Or else, so this can be asked in another way. You just write the question for this. Derive an expression for. Are you able to see my screen?
No, sir.
No, sir.
Okay. Frequency sampling, designing of FIR filter. Or you just write a question. This can be asked in examination as a theory part also. Just write down the question. Derive an expression for. Derive an expression for system function. Derive an expression for system function if the unit sample response, if the unit sample response h of n is obtained, h of n is obtained using frequency sampling technique. Using frequency sampling technique. Can anyone read the question? So please read the question. Hello, am I audible? Am I audible?
Yes, sir.
Can anyone read the question?
Derive an expression for system function if the unit sample response h of n is obtained using frequency sampling technique.
Okay, done. So here already most of things we have studied, just we have to obtain it with the proper step. So first you write down, let h of n is the filter coefficient. You just write h of n is the filter coefficient of an FIR filter, and h of k is the DFT of h of n, and h of k is the DFT of h of n. Then we have what is the formula of IDFT? Can anyone tell me? What is the formula of IDFT? Then we have, what is the formula of IDFT? Can anyone tell me?
Y of n equal to 1 upon n omega n raised to minus kn into y of k.
Okay, so that is in short you have to and suppose if I want to write it in a summation form, how do you write that? So here as h of n is given as h of n equals to, अभी बताएंगे ये form में, because we are considering this h of n is the filter coefficient here, and if I want to write the IDFT formula for this, so I'm going to write it as h of n equals to 1 by n summation k equals to 0 to n minus 1. What I can write here? h of k into e power j 2 pi k n by n for n equals to 0, 1 up to n minus 1. Let us call it as equation 1. Are you getting this point? h of n equals to 1 by n, k equals to 0 to n minus 1, h of k. If you are not understanding at any point my writing, please ask me. E power j 2 pi k n by n for n equals to 0, 1 up to n minus 1, where what is h of k here? Where what will be h of k? h of k का फॉर्मूला क्या आएगा अभी आपका? Yes? Anybody? What is the formula of DFT?
Summation n from 0 to n minus 1, h of n e power minus j 2 pi k n by n.
Okay, summation n 0 to n minus 1, h of n into e power minus j 2 pi k n by n, where the value of k is again k equals to 0, 1 up to n minus 1. Let's call it as equation 2. Okay. Is any new term I have written here? कुछ नया लिखा है क्या मैंने? हेलो हेलो, आज क्या मौन है क्या सबका? Are you all there? Can you anyone give me the response?
Yes, sir.
काय सगळ्यांनी गप्पच बसायला लागलाय की का वर्गी? का लेक्चर बंद करायचं का मग? If you are not responding properly. So I asked the question that have I written anything new here?
No, sir.
The thing like h of n already we know it is a formula of IDFT, and h of k we know that the formula of DFT, right? So you just write after that one line, and we have understood the relation between the DFT and Z transform. Can anyone tell me what is that relation? What is the relation in DFT and Z transform? What is the relation in DFT and Z transform? Just note down one line. The DFT sample h of k, the DFT sample h of k for an FIR sequence, the DFT samples h of k for an FIR sequence can be regarded as samples of the filter, can be regarded as the samples of the filter, full stop. Z transform evaluated at n points, equally spaced around the unit circle, that is h of k is equals to, we can write h of z. Can anyone tell me the condition? I'm just using the notation change here. What is the z value here? Z equals to e power j 2 pi k by n. Let's call it as equation 3. This is again a relation between DFT and Z transform. बराबर? वहां पे हमने क्या लिखे थे? सिर्फ x of k और x of z लिखे थे. The notation I am just changed here. It is like h of k and h of z. H of k equals to h of z, at z equals to e power j 2 pi k by n. Any difficulty up to this point?
No, sir.
Next point you just write. The transfer function h of z, the transfer function h of z of an FIR filter, the transfer function h of z of an FIR filter with impulse response, the transfer function h of z of an FIR filter with impulse response is given by, with impulse response is given by, what is the definition of Z transform? What is the definition of Z transform? Yes, anybody? How do you write equation of Z transform? Hello? What is the definition of Z transform? Any problem is there? Sipra,
Yes, sir.
are you there? Huh.
Yes, sir.
Is there any problem?
No, sir.
Then why I am not finding any responses? अगर कुछ difficult है तो बताओ यार, such that I can understand. Simply sitting idle is not the solution for all the things. Any problem, any difficulty? So at least if you don't know the answer, you can say no, sir. We don't know. That response also you can give, na? What is the definition of Z transform? See, I'm not telling any new thing to you. Just I'm using the different formulas and we are just properly writing that and we are reaching the conclusion. Or should I declare that the unit 5 is over? Can we do that way? Hello?
X of z is equal to summation n is equal to 0 to infinity xn z raised to minus n.
Okay. So that is the definition of Z transform. But here we are using it for FIR filter. Then what should be the limit?
N minus 1.
Yes, it should not be infinite. So in that case, so what we will write is, खरंच काय problem नाही ना?
No, sir.
नक्की. ना एवढं silent, I am just feeling something bad. I don't know. And strength is also very less today. It is around 49. आज फुल डे लेक्चर होने वाले हैं क्या?
हाँ, sir.
Don't worry. Maybe unofficially I am telling you, after 2 lectures, the lectures are going to be suspended. Maybe your CC will tell you still, but you just wait for his instruction. एवढं थकलंय का आता सगळ्यांनी? हॅलो?
हाँ, sir.
कशामुळे एवढं थकान आलंय?
सर वीकली हॉलिडे नहीं मिला ना.
वाह 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 वाह. उसकी वजह से क्या?
हाँ शायद उसकी वजह से.
इतना साइलेंट? होप यू हैव लाइक सीरियसली अटेंडेड द सेशन देन. कितने लोग सीरियसली अटेंड किए सेशन?
Yes sir.
आई एम जस्ट आस्किंग लाइक everyone. And if you attended it seriously, hope you have got a good experience on that part. So abhi how many of you are going to do the project on robotics after attending the session? At least like 2-3 projects like should come out of that part. Anybody has taken that task? Yes. Anyone has decided that yes, I will go the project on robotics? You got a good opportunity to interact, or you got a good opportunity to have like words with such a great experienced persons. रोबोटिक्स का अटेंड किया गया सबने? आई मे बी इट इज ऑन थर्ड और फोर्थ डे सेशन. फोर्थ डे था ना? हेलो,
हाँ sir.
फोर्थ डे सेशन था.
हाँ.
तो कंप्लीटली यू अंडरस्टूड? हाउ मेनी हैव यू अंडरस्टूड इट कंप्लीटली? That one software he has taught you. Which software it is? Which software he has taught you during robotic session? बताएंगे कोई मुझे?
Tinkercad.
Tinkercad. Very good. कौन? योगेश शायद का?
Yes sir.
Okay. Have you got more interest on that? Yogesh.
Little bit.
See, at least we will not understand like 100%. So we have to start working on that. जब तक हम खुद से नहीं करेंगे तब तक कोई सॉफ्टवेयर हमें उतना आसान नहीं लगेगा. एटलीस्ट एक पाथ तो मिला है अभी हम लोगों को, राइट? So we can work on that and we can start working or start implementing the things. Even that Tinkercad software you can use for simulating our normal experiments also. सब components मिलेंगे आपको वहां पे. All your like resistance, capacitance, inductance, ICs, everything is going to be available, and that is a open source software. कितने लोगों ने डिसाइड किया है कि we will work on this area now? Anybody has decided on that part? केलं का कोणी? ठरलंय का त्याचं? तो फिर अभी लेक्चर कैंसिल मत करो सर, बोलना पड़ेगा. So I will suggest your CC to continue the sessions. बोल दो क्या वैसा? हाँ?
नहीं sir.
फिर क्या? फिर आप लोग you are not at all giving any answers. चलो, anyway, we'll continue. So where we are? Definition of Z transform. What we are going to write here? So here h of z equals to, I will write it as h of z is equals to summation n equals to 0 to n minus 1 h of n into z power minus n. Let's call it as equation 4. Okay. Now, next line is just write using equation 1. Using equation 1. Equation 1. equation 4 becomes, using equation 1, equation 4 becomes, what we can write? We can write it as h of z equals to summation n equals to 0 to n minus 1. H of z equals to n equals to 0 to n minus 1. Here I am just substituting the value of h of n. What is h of n here? So it is 1 by n summation k equals to 0 to n minus 1 h of k into e power j 2 pi kn by n. So this is what the value of h of n I am substituting, which is multiplied by z power minus n, which is multiplied by z power minus n. Okay. Then if you further simplify this, I can write it as okay. I can simplify this further, which will be equals to summation k equals to 0 to n minus 1. I can write it is h of k divided by n into, next part I will write it as summation n equals to 0 to n minus 1 e power j 2 pi k by n into z inverse to the power n again. Or further it can be simplified as summation k equals to 0 to n minus 1. This h of k by n will remain as it is into, now this is one of the standard formula, like n equals to 0 to n minus 1 a to the power n. So what we can write for this? What is the formula we are having? Can anyone tell me? What is the formula for this? Summation n equals to 0 to n minus 1 a to the power n. I have given you the list of formulas also. I don't know how many of you are remembered that. Okay. So let me write it here. According to that standard formula, it is 1 minus e power j 2 pi k by n into z inverse whole to the power n divided by 1 minus e power j 2 pi k by n into z inverse. Okay. Then further this can be written as will be equals to, what is the value of this here e power j 2 pi k n? What is its value? इसका वैल्यू क्या होता है अभी? Can anyone tell me? Hello? What is its value? e power j 2 pi k का वैल्यू क्या है?
1.
It's 1. So I can write it as simply 1 minus z to the power. तो ये part complete 1 हो रहा है यहाँ पे. So z power minus 1 is there. So if I take this outside, so it is like going to be z power minus n divided by n again. You able to see this? The z power minus n and divided by n. I'm just writing this part. So this part and divided by n, then into, we'll write it as summation k equals to 0 to n minus 1 h of k divided by 1 minus e power j 2 pi k by n into z inverse. So let us call this as equation number 5. Let us call it as equation number 5. Hope you understood this simplification. Any confusion here?
No, sir. Understood.
Then further we are writing it as, we know that, just write one line. We know that h of e power j omega, we know that h of e power j omega is equals to h of e power j omega at, we can write omega equals to 2 pi k by n, which is equals to h of e power j 2 pi kn by n, which we are writing it as simply the h of k. So that is what, same as our just definition of h of k, the way how we have evaluated. Just add one line here. That is h of k is, h of k is, what is h of k here? Can anyone tell me? H of k stands for what? Or for your better understanding, what is x of k?
DFT of x of n.
DFT of x of n. Now here h of k is DFT of h of n. Getting my point?
Yes, sir.
H of k is a DFT of h of n. Then h of k, you just write one line. H of k is kth DFT component. H of k is the kth DFT component obtained by sampling the frequency response h of e power j omega, sampling the frequency response h of e power j omega, full stop. As this approach, full stop, as this approach for designing FIR filter, is called the frequency sampling method. Hope you understood this. Any difficulty here?
No, sir.
Okay, let's go to the next point. That is a frequency response. Like how to find a frequency response here. You may expect this as a theory question again. Frequency response. So how do you find a frequency response? क्या चेंज करने से आपको frequency response मिलेगा in above equation? Can anyone tell me? In equation 5, with the equation 5 I want to change, or I want to find the frequency response. So what should be the factor I need to change? कोई बताएंगे? And already we have done this part. Okay, let's write down the frequency response of the FIR filter. The frequency response of the FIR filter. Frequency response of the FIR filter can be obtained by frequency response of the FIR filter can be obtained by setting SETTING can be obtained by setting Z equals to e power j omega, Z equals to e power j omega in equation 5. In equation 5. What is that we are going to write? H of e power j omega, H of e power j omega, or simply we can write omega also, is equals to क्या है अपना 1 minus this z, I am replacing it by the value e power j omega. So what I will write here? So we can write it as 1 minus e power minus j omega n divided by n summation k equals to 0 to n minus 1 h of k divided by 1 minus e power j 2 pi k by n into e power minus j omega. That z power minus 1 is there, so I am writing it as z power minus j omega. So now further this can be simplified as so any difficulty here? Any confusion?
No, sir.
Hope you are understanding. Now further how we can simplify this is equals to, we can simplify it as is equals to, so here I wanted to write this is equals to, it is e power minus j omega n by 2 into e power j omega n by 2 minus e power minus j omega n by 2 divided by n into summation k equals Hello, are you all there?
Yes, sir. Yes,
Sorry,
sir.
due to electricity problem, it was disconnected. Let us continue there. So what we have written? So I have written the h of e power j omega h of e power j omega is equals to what
Sir,
we have written
screen
is
is not visible.
okay. Is it visible now? Is equals to 1 minus e power j omega n by 2 summation k equals to 0 to n minus 1 h of k divided by 1 minus e power j 2 pi k by n into e power minus j omega. Okay. Further, this can be simplified as e power minus j omega n by 2 I am just taking as a common into e power j omega n by 2 minus e power minus j omega n by 2 divided by n into summation k equals to 0 to n minus 1 h of k divided by 1 minus e power minus j. What we can write is simply it is omega minus 2 pi k by n. And this can be further simplified as what we can write further it is. So hope you are understanding this part. क्या लिखा मैंने? So if I take this multiplication of this point and this point, so what we will get? It is same as 1 again minus. If I take multiplication of this term and this term, it is like again e power j omega n by n. Okay. So that's the way how we have written that. And further, if I simplify this, I can write it as simply e power minus j omega n by 2 by n into summation k equals to 0 to n minus 1 h of k into, again further we are simplifying this, e power j omega n by 2 minus e power minus j omega n by 2 divided by e power minus j omega by 2 minus pi k by n, which is multiplied with again e power j omega by 2 minus pi k by n minus e power minus j omega by 2 minus pi k by n minus pi k by n. So this is just I am simplifying, and further this can be written as so I will just write here the last step. So finally what we are going to write is the value is minus 1 to the power k into sine omega n by 2. is the simplified answer. This is what the frequency response we are going to get, e power j omega, right? So this is what the simplified answer we will get. So h of e power j omega equals to minus 1 to the power sine omega n by 2. Am I audible now?
Yes, sir.
बीच में डिस्कनेक्ट हुआ था क्या?
हाँ, sir.
So is this screen is हाँ, have you noted this part?
Yes, sir. Noted.
Okay, so this is the way how we are calculating the frequency response. So we will stop it here. Further, we will discuss on the procedure of like various procedure for designing an FIR filter using the frequency sampling method, and then we will take an example. We'll stop it here.
बऱ्यापैकी झालेली आहे सगळं अपडेट फक्त आता अजून काय काय चेंजेस आहेत ते मी प्रिंट काढून करणार राहते आणि माझं हे जो पण रेकॉर्ड करते
बजेटचं मीटिंग आहे माझं
3:30 वाजता वगैरे आपण एकदा रिव्ह्यू घेऊ सगळं